Welcome to video 11.3. Today we're going to be talking about graphing quadratics. So how do we graph our parabolas? Well, when we graph our parabolas, we're going to do the things that we've already talked about. We're going to start by finding the axis of symmetry because that's going to show us the important part of the graph that we need to make sure we show. Because if we only show, say for example, where the graph is going downward, that won't show a parabola. It might just look like a line or even an exponential function. So we have to make sure that we see that part where it starts turning around and going the other direction. So we do that by finding the axis of symmetry. So it's no surprise then that the first thing that we need to do is find the axis of symmetry by using the formula that you already learned in the day one video. Once we found the axis of symmetry by using the formula, we're going to make a table of values with the axis of symmetry x value in the middle. And that makes sense because if we start at that x value in the middle and we show 3 points that are to the left and 3 points that are to the right, that'll show us the nice U shape that makes the parabola. Then we will plot the points on the graph. So let's start by going through an example. We want to graph the parabola y equals x squared minus 4x. So the first thing that we need to do is find the axis of symmetry using the formula. So let's start by writing the formula down. The formula is x equals negative b over 2a. Well, in order to fill that in, I have to write down what a and b are. So off to the side, I'm going to write down a equals 1 and b equals negative 4. Then I'm going to go to my formula, and where I wrote negative b, I'm going to replace it in the line below with negative 4. So now it becomes negative 4. And 2 times a, I'm going to replace the a with 1, 2 times 1. Then in the next step, I'm going to simplify that to become x equals 4 divided by 2, and 4 divided by 2 is 2. So why is that helpful? That's helpful because that tells me that in the middle of my table, I want to make sure that I have the 2 value. So I'm going to write my table, and I'm going to make sure that the 2 goes right in the middle of my table of values. And then I'm going to fill in 3 points above and 3 below. On your table, you should see this part of the graph. We're looking for that symmetry, the same on both sides, so that we can see that we have definitely graphed a part of the parabola, which will show us a parabola, where we have that nice U shape. We can see as far as it needs to go so that we make sure that it's a U on both sides of the axis of symmetry. So that's why it's very important to follow these steps. Always show the work to find your axis of symmetry, and then use that to fill in your table. When we get that value, like for instance 2, we go count back 3, so 1, 0, negative 1, and up 3, 3, 4, 5, so that we make sure that, again, we see that nice part of the graph. And then we can go ahead and plot all of those points. And once we have plotted those points, and I'm sure you probably can do a little bit better than I did, but that's the best I can do with the iPad, and then we can connect them with a smooth curve that connects and arrows on both sides so that it continues. So now that we have our parabola graphed, we can look at the question that says identify the domain and range. So remember, domain means our x values and range means our y values. So I'm going to start with the domain. Above the word domain, write x values. And then above range, write y values. So like I said, we're going to start with the domain. So when I think of domain, I'm going to look at the x values. So we start over on this side of the graph, and then we look and say, okay, well, what's the first x value I have? Well, I see this arrow here. That means that this continues left forever. So the domain would start at negative infinity. And since it's negative infinity, we know that that has to be a parentheses because it's not included. Okay, so we looked at the smallest values, the left values over here. Now we're going to go to the right and say, okay, well, what's the biggest? Well, I also see an arrow going this way, so that means that it's going to go right forever. So the domain would be from negative infinity, comma, infinity. Now, when we talk about range, we're going to, again, go lowest to highest. So the smallest value at the bottom of the graph, I can see that the first time I would hit the graph, if I came from the bottom, would be right here. And what y value is that? That's this y value right here. So just count down to find out it's down 1, 2, 3, 4. We can also see it on the table. So the range starts at negative 4. And since it's actually a point there, we're going to use a bracket to say that it starts at negative 4 and is equal to negative 4. Then when I look at the top, I can see that there's arrows going up forever, so the range goes to infinity. And remember, infinity gets a parenthesis because we can't actually touch that as a point. Okay, The next question says, is y equals x squared minus 4x a function, and explain? Well, we know if it's a function, we can use the vertical line test and it'll only go through the graph at one point. So if I think of taking your pen or pencil, and if you start at the left-hand side and you travel across the graph, that pencil or pen will only go through the graph at one place, no matter where we put it along this x-axis. So that tells me that it is a function. But the reason is more specific than just passing the vertical line test. You can say that it does, but that's not a good enough explanation. You have to say what that means. So passing the vertical line test means that every input has a unique output, or every input has one and only one output. And that I wrote both there because your teacher might have specifically said one of those two definitions. If it's a little different from what your teacher wrote, just use the vocabulary that your teacher has used all year long. Okay, so another example, we need to graph y equals 2x squared minus 4x minus 8. So what do we do first? We need to identify the a and b values specifically because we need them for the axis of symmetry. Then we use the axis of symmetry formula, which is x equals negative b over 2a. Then go ahead and fill in the a and b values and see if you can find the axis of symmetry before moving on. So when we sub those in, we have a negative 4, which becomes 4, 2 times 2 becomes 4, and 4 divided by 4 is 1. So my axis of symmetry is at an x value of 1. So the whole point of this is so I know the middle value of my table. So I'll put that 1 in the middle of my table. Then I know I need to go back 3 and up 3. So backwards goes to 0, -1, -2, and then up goes 2, 3, 4. Now I can go to y equals in my calculator, then plug in the 2x squared minus 4x minus 8, all in y equals, then hit second graph to look at the table of values, and you should get these x values on your screen. So we need to make sure that we start with a -2. Once you see the -2, you can go and get the y values that are paired with these x values. So then when you do this, your table should look like mine does. So I have the 8, -2, -8, -10, -8, -2, and 8. I'm confident in this answer because I can see that the values repeat on each side of my axis of symmetry or turning point that I have in the middle here. I'll go ahead and graph those points. So once you have all those points and you've graphed them, now we can connect them with a smooth curve. So yours might look a little better than mine, the best that I can do on an iPad here, but you want to just connect. The reason I say smooth curve is because we're not using a ruler. It's not jagged. It comes down kind of similar to when we graph like exponentials, with being careful to kind of curve as we go, but parabolas are different because they obviously come back up the other way. So your graph should look something like mine. Now identify the domain and range. So remember, domain are x values, range are y values. When I start with the domain, those are our x values. So the first time I go from the left-hand side, the first time I hit the graph, I see, oh, there's an arrow, so that means it goes left forever. So I start with -infinity. And remember, parentheses around that because the -infinity cannot be included. It's not actually a point that I can reach. And then when I continue on my graph and I look to the right side, I also see, oh, there's an arrow here too. That means it goes right to infinity. Now range, those are my y values, so I'm going to start at the bottom of my graph, and the first time I hit the graph is actually right here, so the y value there is a -10. And since it's actually a point on the graph, I used a bracket to say that it actually does equal the value of -10. And then when I look at the top, I see, oh, arrows. That means that it goes up forever, so the range goes to infinity. And again, that gets parentheses because that's not actually a point that I can reach on my graph. Okay, the next question says, is our graph a function, and explain? So similar to what we did before. So give this one a try before writing what I have. And I actually just rewrote what we did before. The graph is a function because it passes the vertical line test, meaning every input has a unique output, or that every input has one and only one output. Okay, so question number 3 says we need to graph f of x equals -x squared minus 2x plus 3. And then it tells you this -4 is less than or equal to x is less than or equal to 2. That is an interval. And it means that your table should only cover those x values from -4 to 2 because the graph only exists between the x value of -4 and 2. So we don't have to do the axis of symmetry for this one, because they're telling you start at -4 and go up to 2. So all we need to do is put this in y equals, so y equals negative x squared minus 2x plus 3. Then hit second graph to take a look at the table and start at an x value of negative 4. When you do that, hopefully you get the same table of values here. So we start at negative 4, and that's paired with a negative 5, and then negative 3, 0, negative 2, 3, negative 1, 4, 0, 3, 1, 0, and 2, negative 5. Then we can go ahead and plot these points on the graph. Now, once we've plotted our points, we're going to connect with a smooth curve, but this time we're not going to put arrows because remember, it only exists between an x value of negative 4 and 2, so it needs to stop at those 2 points. And since they're included, that's why the points are solid points on the graph. Okay, so your graph hopefully looks like mine, and then the next question says identify the domain and range. So again, we'll write down x values above the domain and y values above the range. So when we look at domain, the furthest left that this graph goes, when we come from the left side, I can see that the first point happens right here. So that's at an x value of negative 4. Now remember, we also need a bracket around that because the negative 4 is a point and it's a closed dot on the graph. And then when we look to the right, we can say, okay, and the furthest right this graph goes is to right here, which is an x value of 2. So our domain goes from negative 4 comma 2, and both of those are included. So for the range, we talk about the lowest the graph goes, and if I look here, this is the lowest that the graph goes. When I go from the bottom, the first time I hit the graph is at this y value right here. So that y value would be negative 5. And again, it was included, so I used a bracket around the negative 5. And then when I look at the highest the graph goes, the highest it goes is right here, and that is a y value of 4. So my range is from negative 5 to 4, and both of those points are included because they have the solid points on the graph. The next question says, is the graph a function? And explain. Well, similar to what we said before, the graph is a function because it passes the vertical line test, but remember that's not enough. So I also said meaning every input has a unique output. Or your teacher might have said every input has one and only one output. However you write that, but just basically showing that the inputs don't repeat. Okay, the next question says, what is the turning point of the parabola represented by y equals negative x squared plus 6x minus 4? So in order to find the turning point, we need to first find the axis of symmetry. So how do we do that? Start with the axis of symmetry formula, x equals negative b over 2a. Then replace the information that you know. Off to the side, I wrote down a equals negative 1 and b equals 6. So now I can replace the a and b value in the formula. Okay, so now I have x equals, and then the negative parentheses where I subbed in the 6 value, divided by 2, sub in negative 1 in parentheses. Now, depending on your calculator, you're going to simplify this in whichever way makes most sense to you, either by putting it all in as a fraction, or putting the numerator in parentheses and the denominator in parentheses, or cleaning up the numerator, cleaning up the denominator, and dividing at the end. Whichever way you do it, hopefully you match my x value. X equals 3. Now that I know the x value for where the turning point happens on the x-axis, I don't know what the y value is. So if I know x, I can substitute it in place of x in the equation to find out the y value. Pause the video and give that a try before checking with my answer. Hopefully you got a y value of 5, but I'm not done yet. The question asked me for the turning point. So the last part is to write it as a point, x comma y, so 3 comma 5 is my answer. Okay, last question says to write a quadratic equation for a function that has the zeros of 5 and negative 2. So that means that my x values for the zeros, the x values are 5 and negative 2. So I can write that as x equals 5 and x equals negative 2. Now pause the video and give this a try. This is just like what we did in the previous video where we found the roots and worked backwards to write the equation. Okay, so we do this by solving for when x equals 5. We want to work backwards to get it back to equals 0. And then we can figure out the factor that that root had come from. So To change this to be equal to 0, we subtract 5 from both sides. That gives us x minus 5 as one of the factors. To get this one equal to 0, we add 2 to both sides to show that x plus 2 is the other factor. Now, this is an equation, but we always want to write them in standard form. So now I'm going to use the area model to simplify. So we have the x and the minus 5 and then the x plus 2. Then we multiply to fill in all of the boxes. So x times x, that'll fill in this first cell on the left here. That becomes x squared. And then the negative 5 times the x becomes a negative 5x. And 2 times x becomes a 2x. And then in the last cell, negative 5 times 2 is a negative 10. Then we look for any like terms. Usually they show up on the diagonal as they do here. I have a negative 5x and 2x. Those can combine to become negative 3x, and then we can write our equation, y equals x squared minus 3x minus 10. And you could check this in your calculator to make sure that it had the correct roots by putting it in y equals and then looking at the graph or the table. Because there was no graph to match, I don't have to worry about if this was a negative or a positive. So this is my answer. Now your task is to try homework 3. Have a good night.